Hello, these are the exercises for Chapter 3, Section 5. A researcher wishes to estimate the proportion of households that have high-speed internet. So what sample size should be obtained if she wishes to estimate to be within 3 percentage points with a 95% confidence if she uses a 2009 estimate of 63.5%. So we want to find our sample size. So if you look at your lecture notes and your formula sheet and you get a formula that is n is greater than or equal to z star squared times p times 1 minus p divided by your margin of error squared. So z star is your critical value, your p is preliminary estimates from similar studies, etc. And this ME is our margin of error. Okay. So we have to go through and figure out all this information. So also in your lecture notes, we have critical values, and those are your Z stars. Okay, so we want to find a 95% confidence level. So my Z star will be 1.96 squared. My preliminary estimate is from my 2009, and that's going to be 0.635, and then I have 1 minus 0.635 divided by my margin of error, and that's within 3 percentage points. So we are not using percentages, we're using decimals, so we have to go through and make it 0.03 squared. We can go to our calculator to get this done. I'll just use GeoGebra real quick. Okay, so I'm going to use double parentheses, and I'm going to have 1.96 squared times 0.635 times 1 minus 0.635. I'm going to divide that whole thing by 0.03 squared. Okay, so I have 989.32. So that this means that my n has to be greater than or equal to 989.32 people. So if I need to have an integer number of people because I can't have 0.32 people, then I have to have 990 people in my sample. So down here they ask you to kind of have some conceptual understanding of this sample size. It says you do not need to recalculate the sample sizes, but you can if you need to. Okay, so I'll do this first one as recalculating so you can kind of see what is going on, but we're kind of just reason it through a little bit. Okay, so she wishes the estimate to be within 2 percentage points. So if I wanted to be within 2 percentage points, then I would come here, and instead of saying 0.03, I would have had 0.02, and then I push enter, and I get 2,225.97 people. So as you can see, it got larger. Okay, so let's think about what that means conceptually. So if you want to have all the same confidence intervals and all the same previous estimates, but you want to have it a smaller range, you're going to have more people to be able to do that because you want to have it a better estimate for the population. Okay, if you want to have it a little bit worse estimate for the population, then you can have a smaller sample size. So now let's think about confidence level. So if I originally wanted to have a 95% confidence, and now I want to have lesser confidence and have 90% confidence. Okay, so again, we could go back, and this is what we had originally. Okay, if I wanted to instead have it be 90% confidence, that's what's going to change our critical value, and we'd have 1.65. So instead of 1.96, we'd have 1.65 squared, and you get 701.12, so 702 people. So it went and got smaller. So let's think about why this is the case. So if we wanted to have more confidence that our interval contained the true parameter, and then we changed to having less confidence, we could have a smaller interval and it would be okay. So if we want to have a smaller confidence, then we can ask fewer people because we don't have to be as accurate. We don't have to have as good of a prediction. Okay. Similarly, if I want to have more confidence that I contain it, I want to have more people in my sample because I want to have a better prediction. Okay. So if we don't have a prior estimate, then we are going to be utilizing the formula as n greater than or equal to z star squared times 0.25 over my margin of error squared. Okay. So our estimate now is that we had 63.5%. If we have no preliminary estimate, we're saying that these two options have equal chance and it's 50%. So basically we're having if the prior estimate is less than it was before. Okay. So if I had changed my number here, so this was for the original one was 9, 6. I messed up my formatting. Squared. And then having no preliminary estimate is using your preliminary estimate as 0.5. So we needed 1,068 people there. So we needed it to be bigger. So we needed to have it as a larger estimate. So let's think about why this is the case. Okay. So when we are multiplying in our formula here, if I have 0.635 times 1 minus 0.635, that's going to be a bigger number than if I have, one second. So if I have 0.635, let's just do it real quick. So I have 0.635 times 1 minus 0.635, it becomes smaller, 0.23. So we're going to have a smaller number on the top here than if I had no estimate at all. Okay, so that means that we're going to need more people if we don't have any prior estimate. And then similarly, if we have an estimate that's higher than we had before, we're going to have fewer people. Okay, so we are going to have it more shifted to these different regions, and then you can go through and test your sample size. Okay, and again, you don't need to recalculate the sample size, but you can always do that if the reasoning isn't quite, you're not confident about the reasoning. Okay, have a good day.